All right, hello, folks. Welcome, everybody. Thank you all for making it out. Day 3 of the Nagios World Conference. My name is Emmett. I'm the announcer today. And up next, we have Anders Hual, founder and senior consultant at Ingby. Go ahead, give him a big round of applause.
Thank you very much. And thank you, Emmett, and all of your colleagues to making this conference so great. It's always a pleasure to be here. Well, the presentation today I've called Why Dynamic and Adaptive Thresholds Matters, and especially why it matters in the scope of Nagios monitoring, of course. I was planning to call this presentation maybe why is static thresholds not enough? And that is really the essence of this presentation, to show you a little bit of a different type of capabilities that you may be needing when you're dealing with thresholds. Like Emmett already said, my name is Anders Hual. I work for a Swedish-based consultancy company out of Stockholm. And we do mainly development, project management, operation stuff. And we work predominantly in the financial and transportation industry. Much of the things that I will present you today is something that we have put into a project called BizCheck, which is sort of an add-on to Nagios that will have implementation of much of the stuff I will talk about today. And this project is fully open source, GPL, and has been sponsored very much from DHL in Sweden, in the Nordic area. So giving them some credit to understand that open source code can be beneficial even if you are a big commercial company. It took some time to convince them, though. Well, let's start out with thresholds. From my point of view, thresholds is really the most essential part in monitoring. If we didn't have any threshold, it wouldn't be monitoring. It would just be we measure stuff and we put them on graphs. But the threshold is really what kicks off everything that has to do with alarms and the notification process. So it's really key to get them accurate. So I mean, the threshold really defines the boundary of what we expect as a proper behavior of the thing we monitor. And if that breaks, we get a failure if we break that threshold. And what we typically do, we define thresholds like the thing I'm monitoring should be above a threshold, or under a threshold, or it should be in some sort of interval of a threshold. But exactly as this picture is showing, the type of threshold we define in Nagios, for example, is static. So we say for all time until I change it manually, it should be 20 tons. This is the threshold probably for a bridge somewhere. And this is really the whole problem, because it's not enough, from my point of view, or what we have experienced working with customers, to have that type of limitation a static threshold is. And the limitation is basically that the thing we monitor is not static to its nature. It varies. It varies over a day period, the load of CPU, or how much rows we have in a table, or how many orders we get into a system is different over the whole period of some time period. And typically a day is the time period we typically work with. What we tend to also get if we have this sort of static, very sort of non-very granular thresholding, we get typically too few alarms or too many. And typically when we get too many alarms, what do? We change the threshold so we don't alarm that much. And typically what you get if you have something you're monitoring that have a very high variation, you set it to the max or to the mean, but it's not really catching everything in between there. So you need to be able to have a finer granularity on your threshold. The other thing we have seen Nagios is great. We love it. We all love it here. But from a design point of view, what I've seen is that the sort of design we have with the check commands is we give all the responsibility to the check command to do everything. It's collecting the data, and it's also evaluating if the collected data is in the threshold boundaries or not. And that check command is typically kicked off, doing its job, and then dies. So everything that's going on is very much in its own context. So you don't have anything that are like historical data that you can use to calculate your threshold from. And also with the design we have with this sort of check commands is that the most, we're only considering what I'm currently retrieving from what I'm monitoring. So I'm just in that scope. And then if I need to have something that this thing that I'm monitoring is depending on something else, especially from a threshold point of view, I don't have that capabilities. I mean, we can all write code, so now many of you think, well, sure, I can write that in my check command. And that's true, and that is more or less what we did. We wrote a really complicated check command to do this. So what I'm gaining at here is that we need to have something that is more dynamic. Exactly as this speed sign tried to give you an impression of is we can change the speed that we communicate to the driver on the road depending on some circumstances around it. It's not always 60 miles per hour. It's not always that threshold. Depending maybe on the time of the day, I want people to slow down because I know it would be more traffic, so I decrease the speed limit. Or I discover we have a traffic jam in front of us or a traffic accident. We also need to decrease that threshold or change it. And exactly the same thing we want to have in monitoring, or that's my point anyway. To try to give you some feeling what I mean here is I will try to give you some examples. And let's start with the first example. Here we have some sort of database table that is get filled and removed stuff from. And I want to define a threshold that it should not be bigger than 5% of the maximum number of rows size it was in the table yesterday. To be able to solve this, we need to, first of all, track how much what we collected, how many rows it had in that table yesterday, store that somewhere. And today, when we make this we're doing the monitoring and checking for it, we need to retrieve that maximum value we had yesterday from in some sort of mathematical evaluation, max function, and multiply it with 1.05 to get that this table size should be below that threshold. So that would be my threshold calculation. And this show we need to have access to historical data. We also need to apply some mathematical or statistical functions when we're calculating thresholds. The next example here is that we have some sort of system where we have a number of online users that should not be more than 10% higher than the average of the number of online users that we had for the last data points when we collected how many online users it was. So let's say we have an average, we have 5 minutes interval between collecting them. That means I want to look back at the latest 50 minutes to understand how much online users I had. And again, we need to store the data that we collect. The hard drive is a picture of storing data. We need to store it somewhere. And then we need to retrieve that list of the historical data of how many online users we had for the last 50 minutes. Would be the 10 data points from X0 to X9, and calculate the average and multiply it with some sort of number, in this case 1.1, to calculate that we don't have a threshold, we don't have number of users over that threshold. Let's look at the third example. In this case, we have more business. I hope it doesn't scare you off. But here we have some sort of application we're monitoring. And we want to understand and we want to have an alarm if the number of orders we get into the system, let's say we have some EDI flowing with orders, if the number of orders with some sort of errors in the data is about 5% of the total number of orders that we have received, I would like to be alarmed. or I would be notified. Maybe I am alarmed when I get this information. With this example, we really are showing a bit of this sort of adaptiveness. What we're doing here is we need to monitor two different things. Maybe there are two tables in the system, or same table but with different clauses. We need to retrieve the number of orders we have. We need to retrieve the number of orders with arrows we have. But we're using the total number of orders as the foundation for calculating the threshold for the number of orders with arrows. So we're not even, because in this case, you're setting the threshold to how many orders with arrows can you expect? Okay, 2,000. But that doesn't make sense if I have just got 1,500 orders into the system. So I want to be more dynamic. This is hopefully showing you the dynamic of the capabilities. In this last example, and then I won't bother you anymore, we have some sort of message queue with some, maybe that are, I don't know, some random information getting into this message queue. And it typically have a load variation. And in this case, for me, the load variation is important because sometime during the day here, it's very different. It's very low in the morning and the afternoon, but it's peaks during the day. And I really want to make sure that we are above some of these numbers, depending on the time of the day. And maybe it's different. Fridays are different from Wednesdays, and Wednesdays are different from the last day in the month or something. So I need to have making a profile that I can use to calculate my threshold depending on the time of the day. With a static threshold, I could only set sort of, it should always be over what? I mean, it should always be over the least I have, if it's the above I want to track. And I could have the same thing, I want to be below this curve. But I have some sort of threshold curve I want to do the evaluation from when I when I evaluate my threshold for what I'm monitoring. So from this example, what we have seen is that we need to have some sort of capabilities that are about, we need to be able to describe some sort of time profiles for the thresholds. And what we have come to a conclusion is, or from working with this, is a day is a very good time period. Things typically change differently for different days and over a day period. We also need to have some sort of historical data storage. So we can use the historical data that we collected before and use it as thresholds or in our threshold calculation. And we need to have math and statistical operation that we can apply to the data we collect. And we didn't just want to write some sort of new check XYZ for HTTP requests because that was not our scope. We saw this is applicable depending on what type of thing you're monitoring. It can make sense for depending on what type of things you want to do dynamic thresholding on. So we wanted a tool, a framework where we can describe threshold in this way. So from a sort of architecture, Mickey Mouse point of view, the first thing we needed was some way of collecting data, of course. That is core in any type of monitoring system. And you want to be able to collect from different kind of sources, from a database, from web services, whatever. From a JMX in your Java application server. So collecting data. But then the core thing was that we wanted to separate the collection from the threshold calculation. Clear separation. What you collect is just the number, and how you should use that number that you collect is up to the thresholding system. So the first thing we need is some sort of historical data. We can store this data we collect for some period of time anyway. Maybe just a day or maybe a year, I don't know. It should be something that is configurable, of course. Then you need to be able to apply logic, and this is typically math logic. Statistical operation like average, mean, max, running average, whatever you can think about. You should be able to write your own operations and put them in there. And then we needed something that was this sort of day profile, so we can model a threshold over a period of a day with different values depending on the time of the day. And for that day profile we created, we needed to connect that to a calendar. To say that this specific day profile for this threshold is valid for every Friday, or it's valid for the last day of December, or something like that. So you need to have that granularity because it varies depending on what day you are working. So when you have collected the data, you have processed it through your threshold logic, then it's time to send it off to your monitoring system. And then it goes into Nagios. And it goes into Nagios as a standard passive check. So if you have Nagios there, this will work directly. One thing that we saw very early on was that, okay, if I can send this data to Nagios, why not I can send it to any system, any monitoring system. So we wanted to have a separation of the server integration, so you could deploy and develop your own server interfaces, really. One thing we did more or less for testing, but it's a real cool tool. I don't know if anyone has used OpenTSDB or looked at it. It's really, I think you should. It's a really cool tool that do a real-time graphing and monitoring. It has a big Hadoop database as it used to collect a huge number of data. And then you can graph different types of graphs in the same, on the same screen. And you can see your thread pool size compared together with your CPU utilization, etc. So you could just send it. So that was very important for us to be, not just be bound to Nagios, even if that's the most important, of course. And then we said also we want to have some more advanced scheduling mechanism on the collection. Most of the time you want to do interval collection. You collect every 5 minutes or every second or whatever. But for some circumstances we saw from customers we work with, you want to be able to say, you just want to check this at 20 minutes after 10 o'clock every night. And if it's wrong then, it doesn't matter if it becomes okay later. You just want to check that time. So you wanted to have a more advanced scheduler. The sort of architecture or product view we came up with was this sort of, that we implemented was BizCheck. And as you can see, it has the foundation that we have already talked about. You have a connection module that you can connect to different systems with different protocols and different protocols. You have the connections are executed based on the scheduling scheme as defined. And when you connect to something and retrieve data, you put it into the data cache. And then you go on to the threshold and logic. And the way we implemented it was that you can implement your own threshold classes. So maybe you want to have some threshold classes that use the angle of the sun to calculate your thresholds. You can do that. It should be open for that. But the basics that we sort of have in the package is this sort of day profile. And then you can send it off to exactly the different systems you have. And the integration we have with Nagios is over NSCA. But we have recently done if you want to integrate over NRDP instead, the Nagios Remote Data Processor. I don't know if anyone used that or is, yeah, okay. It seems to have some good features though. Especially you can do more simple bulk upload of stuff. And that's something we'll probably look into when we have, if the load gets high, then you can cache it for a while before you send it off to Nagios. Okay. Well, one of the sources that really interesting to retrieve data from is Nagios itself. So you can set up a connection to Nagios over live status and retrieve state data for services or performance data for services. And you can use it then in BizCheck. There is one company in Italy that's testing this currently. They retrieve lots of SNMP data for switches, and that gets into Nagios, and then they retrieve it into BizCheck to do some more aggregation and also some other thresholding calculation on that data. And then they push it back to Nagios as a different service. And for example, you can do, if you get out the state data, you can do Boolean operations on the state data, for example. So lots of stuff you can do. So just some of the basics in BizCheck that could be interesting to know. The configuration is a little bit like Nagios. We're using sort of the same acronyms like host, services, but we also have a thing called service items. A host in BizCheck is just a container of other services. You don't define anything that is to do with a real host because, like the example I said, if you retrieve stuff from live status, it may be about this specific switch, and then you retrieve something else in a different way from that switch too. They are all in the same host, but they're not connected. You don't get the data the same way. Anyway, so the host is just a container of services. And on the service level, you specify how to connect to that system. This is where you have the sort of connection. If it's JDBC or web service or something like that, this is where you describe it. And you also describe how do you schedule that connection. And then you can have a service item, and you can have multiple service items for a service. And it's on the service item level where you specify what you're really executing on that connection you create on the service level. If it's a JDBC connection, you can do SQL for it, of course. So you can do select statement with a where clause to get some interesting data out of your SAP system or some other thing you have. But you also define the threshold class that you're going to use for that specific service item. So that can be different for different service items on the same service. And if you have multiple service items, the sort of the state that you send back to Nagios is the one with the highest severity. So if you have 3 service items, one is critical and the other 2 are okay, it will still be critical to Nagios. And the only configuration you have to do on Nagios side is you need to describe the same host and service name as you have in BizCheck and say that this is a passive service. So just the normal stuff on the Nagios side. Let's skip. So we talked about this sort of 24-hour profile of describing a day profile for thresholds. And as I said before, this is key and used all the. This is what we have seen is the most useful so far as a threshold logic, threshold mechanism. What you do is you have a model that you define, you divide the day in 24 hours, and for each hour you can define a static value or a dynamic value. And a dynamic value means here that you retrieve something from the historical cache and make some sort of math calculation. Or you don't need to make a math calculation, but you can do some calculation on that value. So that will always depend by dynamically be always resolved at runtime. You calculate at runtime. And you can retrieve data from this cache in a number of different ways. You can retrieve them by index, and you can, the index 0 of something that you have stored in your data cache is always the latest stored value, what you have retrieved from what you have collected, the data point you have collected. So 0 is always the latest. It's like a queue in that way. But you can also retrieve by a range, say everything from index 5 to index 100. But you can also retrieve by time, which we've seen was very effective. You can say, I want to retrieve everything of this data value that I had collected from 30 minutes ago to an hour ago. And I get all these values that are in that time space, the time range. And that is typically what you can do when you do average or some sort of statistical calculation of on a list of data. I will not bother you with all the configuration and stuff, but just showing you how it could look like in the sort of from a configuration point of view. For each hour you define, if you have in this case you have a static value, 7,000. At 1 o'clock we define that we're retrieving from the host ERP server the service orders and the service item EDI orders. And we retrieve the last collected data from that. And we divide it by 3. That makes sense probably for the one who did this, why you divide it with 3. But then you can really continue. You can retrieve some other thing and multiply it or divide it or whatever you want to do. So this is just an expression of calculation you express here. And the last example is that here I'm showing you how to retrieve a list of data in a time interval, 30 minutes ago from now to 60 minutes ago from now. And you calculate the average of that and you divide it by 2. The obvious question maybe now is, what happens between the hours? I chunked it up in 24-hour chunks. I specified for each full hour what it should be. And what we do is we really do a linear equation between each of these full hour. So whatever you have defined here, is it a static value or a dynamic value? You calculate, here it's easier to see, the linear equation between these two time intervals. So at 15:30, you will end up here. So it's almost resembling a curve on the granularity of 24 chunks. And that seems to work pretty good so far. And this then the time period, day period that I described, I connect that to a calendar. So I can say this day period is valid for this specific month and day a month. That is the highest, have the highest proceedings when you reviewing what type of what day profile you should use for evaluation. If I have someone that is for this specific day or the month that I'm currently today. And then I can describe it's valid for a week. I don't know if you use a week numbering in US very much. Maybe it's a European thing, but we do it all the time. So it can be a day or week number 2. That would be the second week of January typically. Or, yeah, you can see yourself. And if I don't connect it to any specific calendar, it will be my default profile and used in any other circumstances. I can also describe holidays. Would be more sort of described as exception days. This is a day that I will not do any threshold calculation. Christmas Eve, for example. But it could be other days that make sense for your business where you don't want to have any threshold calculations. Some other stuff that can be interesting with BizCheck, it's totally multi-threaded. It's totally developed in Java. Maybe some here raised their eyes. Maybe not very Nagios-like, but it's totally written in Java. It's run by default, supported on sort of what we do installers for Linux, etc., but should run on Windows. We have some companies that are trying to run it on ACE400s. So it's totally multi-threaded. So every time you kick off a connection and retrieve data, that will go in its own thread. So it's a multi-threaded schema it runs through. And you can define intervals or a cron expression for you who's familiar with Linux and Unix. It's an advanced sort of cron expression you can do. Data collections today are JDBC, live status, and you can also define a service that just retrieves data from the internal cache. In that way, that can be useful, we have seen, if you want to create what we call virtual services. This is typically if you have, an example could be, you're getting orders into a system from two different sources. So you have a web shop number 1 here and a web shop number 2. And you have an expectation that you want to have 80% of the orders coming from this one and 20% from this one. And what you can do is you will, of course, have to retrieve the data from both of these different systems. They will be put in the cache. But then you can write your virtual service that says, I want to have the ratio between these two values. And you have threshold saying, OK, it should be 80-20. Yeah, there is some, for everything that is a query and execution statement, you can have data macros because it will always resolve, especially if you have SQL, for example, you do select to something, you typically do it with some sort of date where date is equal something. And you can then in a macro format describe the format of the date, and it will resolve to the current day when it's running. Or you can also say it was yesterday or 2 days from now. I want to retrieve the data. It's pretty customizable. Everything that is for you who develop in Java is sort of clear interfaces for any type of additional classes you want to write. So every service class that manages connections, you can write your own. For service item that makes the execution, maybe you have some strange system where you're retrieving something in some way. You can write your own. You can also write your own threshold classes. And of course, server integration classes if you want to integrate with HP OpenView or Tivoli. I have never figured out how to do it. And I've Googled anyway. Is there anyone who knows how to do it? OK, no. You're in the right place. No. But it's unbelievable. But it should be possible to do. There is also an XML GUI that exists that you can do configuration of the configuration files. It looks nothing like Mike Guthrie showed yesterday. We're not very much of a GUI developers, so if anybody have their extra time, maybe Mike, but I'll ask him later. And it's also licensed on the GPL too. Stuff we're looking into in the future is really improving how we store the data in the data cache. I mean, we don't want to have a regular database or anything like that, but we're looking into improving that so we can query that data cache in a more effective way and in more ways. One thing that I think many people talk about in our business is baselining or pattern. You want to say, OK, I want the threshold to be like it was on Friday last week, because then it was that was typically a day how the system behaved like it should be. And if it doesn't behave like that, I want to have alarms. And you can implement that today, but I think we could do much better work to do specifying that in different ways so you can have an easy baselining capability. More statistical functions, of course. And the fourth one is that if you have, I don't know if it's the right word, sensor networks, but if you have multiple things that are you're collecting data from, like maybe temperature or something like that, you don't want to have threshold on each of those. You want to collect all the data and make some sort of smart analysis if you should alarm, if all these sensors together making some aggregated information about what I should do alarming on. I think that is an area that could be of interesting too. And any ideas that anyone can have is appreciated. So I think in our business, they talk about so many different things of monitoring. Last year when I was here talking about it, I pitched this whole presentation as a more business activity monitoring. I think that sort of business, okay, I leave the room. But it's maybe this type of thresholding that we used to doing that I talked about today is more important when you come up in more of you want to do process monitoring or on application-specific monitoring. and you have complex system that you want to do thresholding on. But it's really valid on anywhere where you want to have some sort of dynamic thresholds or adaptive thresholds. So independing on infrastructure monitoring, application monitoring, business activity monitoring, or the last acronym I found was operational business intelligence. That sounds great. Sounds expensive. So I think we will call it that in the future. But it's an interesting space because what you tend to do when you go talk to business people about the sort of why don't you monitor and stuff, isn't it important? Well, we have this huge investment in business intelligence. It tells us always 60 days later if it was broken or not. And yeah, that's the point. It tells you later that it's broken. But maybe you need to have something that is more tactical, more operational from a surveillance point of view. And so maybe that's an acronym they will catch up. Well, I was quick today, so thank you very much for listening. Hopefully you have some questions. Give credit to the pictures, was not mine. They are in Creative Commons, so you can find them there. But thank you very much for listening.
Does anybody have any questions?
Hi. So as a potential use case, the first thing that came to mind for me was something along these lines. And I'm curious whether this would be possible with BizCheck. But say I have 50 web servers. And I want to check load, but the usual problems with a static check against load can create a bajillion false alarms. So could BizCheck, say for instance, evaluate the load on my 50 web servers and only alert, say, if load on any one of those boxes was maybe 20% higher than the average for all of them?
Yeah.
Yes?
Definitely. I think this is typically the company in Italy I spoke about that was doing, they are doing more or less a little bit like that. Okay. They already have the data, like you say, they all have already have the load figures in Nagios, but they can't really do the thing you want to do with it. So that's why we really came up with a live status connection. Because you can retrieve it into BizCheck, it goes down to the historical cache there again, and then you can start to do this sort of mathematical calculations on it. So
you'd point BizCheck at the existing load monitors in Nagios for those web servers, pull that data within BizCheck, perform the mathematical analysis, and then kick out a result?
Yeah.
Okay.
And as long as you can retrieve the data from that performance data through live status, it should be fine.
And I had one other question. Is there any potential for pulling in your historic data from alternate sources? For instance, I mean, we've got reams and reams of trending data already saved in RRDs, Whisper files, etc. Is there any option to pull some of that existing data in to use for historical analysis in BizCheck?
Yeah, currently it's not. If you want to do it now, you would need to set up a connection, a service that just goes out and read that data.
Okay.
And you can describe a service as a service that doesn't send anything to Nagios. So that would be a service in BizCheck that just have go out with a connection to the system where you have all this data and retrieve it in some way and store it. I don't think it's a good idea, but that would be one way to do it. But I think that's a good idea to be able to do some sort of online bulk load from other systems. And that is a little bit what I should put in the context of improving the sort of time series data. Currently, it's very much, it's in memory, everything. We save it to disk at times. But it's what we're looking into really is to implement something that is better from that point of view, that you could do more with it, and also from the side do stuff with it. And then it would make sense that you can import data from other sources to that. As long as it's expressed as we express it, like a host service and some service item, then you can use it for anything.
Thanks.
Good question, yeah, good idea.
You have another one?
It's a long trip back to Sweden, so maybe. Yeah. The power is bad, though, on the flights.
So I have two questions. The first, with you said for the holidays that it basically turns off the thresholding.
Yeah.
Is that from a scheduling standpoint then, that it's the checks aren't being run, or is that the checks are being run, they're just returning some sort of default value?
Yeah, the checks are run. You're doing your connections. That's not depending on the holiday at all, as it is now. It's just that if you evaluate that this day was a holiday, you don't do any threshold logic on it. So you still do the connection on it.
Okay, so then that implies then that if you've got something that's based on one of your curves for the day profile, that you've got a value that you choose as the non-threshold value then, is that it basically, for when those holidays are in effect?
Well, what you can do is you can, if you collect during a holiday, you collect the data. You have schedules, so you go out and retrieve the data. It will go down in the cache, in the historical cache, but you will not do any threshold evaluation of it, if you understand what I mean.
Okay, all right.
And if you don't want to have it scheduled on a holiday, we don't really have. I think there is if you have a cron expression, you can define sort of exceptions there for not doing the collection in that case.
Okay, I'm thinking of a specific application that we have that would still be running on a holiday type day, but it would need different values for that day than the traditional sort of profile would be.
But then you would define it as not on holiday. You would define it as not on holiday, but you would define a different day profile for that specific day.
Oh, okay.
So that's how you do it.
All right, that takes care of that problem.
So yeah, so that is really the key with the day profiles. You can map them to different dates or a week number or Fridays or whatever.
Okay.
And you can say that if this is Christmas Eve, you want to still run it. You say, okay, for Christmas Eve, we have this day profile, which is lower than maybe.
Or higher.
Or higher. Yeah, depends.
Okay.
So.
And the second question, I like your idea of sort of the virtual services. And as I understood your quick description of that is basically coordinating multiple checks and aggregating those results, doing some math, and deciding if that's a good value or a bad value as a result, and then reporting that back to Nagios, right?
Exactly.
Okay.
So the virtual service, normally maybe for a service you go out and collect something with a select statement or something. But for a virtual service, you retrieve the data from the data cache. And then your execute statement or query, so to say, is a mathematical expression that could be a sort of calculation the ratio between two different things or something. But you can really do whatever you want.
Okay, thanks.
As long as it goes through the parser.
All right, thank you.
Thank you.
Have you used it to do anything like rate of change? So like you see a disk changing that you may not hit 90% threshold yet, but it's growing at a huge amount, or rates of change over maybe longer than 1 day period, but it's grown 50% in the last week,
Exactly. I mean, I think the example we had is typically like long way to go. Something like this. You want to, because this is typically what annoyed me, like you said. You say 90% of disk space, then alarm me. But I really want to look at the increased speed instead. If it increased very fast, even if it's just 10% filled, I want to understand why it's sort of increasing so fast, or why the number of users increasing so fast, or the number of threads, or whatever. So I don't know what you call it in English. In Swedish, we call it sort of the steepness of the curve, derivation, or anyway, the steepness of the curve can go down or up. And this is exactly what you could do in that case. So that you calculate and measuring relations between the historical data points you have. And this is really an example from one of the companies that tried that was exactly that type of scenario. They needed to understand the growth rate of tables or disk space. And understand it.
What's kind of the longest time frame you've seen that rated over? Like we want to know it's growing this much over a month, a year.
No, not a year. That would be a huge amount of data, and every time doing an average or something like that on that data. I think it's typically in the week time frame data you manage. But this is also in this, a little bit of the what I talked about in the future to increase making this time database better. Because some of the data that you maybe want to look at a year, sort of last month, you don't want to calculate that once again. So you need to want to have a capability of caching the result of what you have already calculated. We don't do that today. We calculate every time. And it's fast, but depending on how much data you, of course, will process, it will become something that increase the load. So I think that is one of the topics to have more. If you calculate it once, sort of last month, it will not change. It's historical. You can cache that.
And do you typically, when you're doing your analysis, are you doing it in like 5-minute intervals, kind of along with the checking interval?
You mean the analysis of?
Yeah. Do you typically do the analysis like every 5 minutes, or do you do it once a day, or?
The analysis. Well, when you calculate in the threshold, you do it at the same. When you collect the data item, you do threshold calculation of that directly. So you don't calculate threshold sort of in a batch, if that's what you're thinking about.
Well, no. I guess I'm thinking if Nagios is going out every 5 minutes and let's say seeing how many users are on my website right now, and then you're retrieving that via live status. How often do you retrieve it from live status?
Oh, it can be up to you. 5 minutes or
I'm just
1
wondering
hour.
what you typically see. That do people actually, if you're averaging like hour profiles?
Yeah.
Do you typically go out every 5 minutes, or do you let it go longer?
I think I don't know if anybody thought about it that way, but yeah, I think the standard is that 5 minutes interval seems to be the normal. But I think one of the things I have heard from people is that this sort of 5 minutes, that is totally useless for us. We need to get down on totally lower intervals, maybe seconds or 5 seconds or something like that for some stuff. So yeah, but it's more up to your needs. You can configure it the way you want.
Yeah, I just didn't know if you'd seen any performance impacts of, let's say, running it every 2 minutes, or
no
value in running it less than every hour, or.
From our point, I don't know on the Nagios side how much the impact is using live status, but on our side, it's not a big thing. If you're interested, everything is in BizCheck. Everything is instrumented by itself, so you can look at everything, every execution time, how long a connection takes, or how long the threshold takes to process. It's available through JMX. We used a guy that worked for a company called Jammer. He did a really great instrumentation tool for JMX for Java. So you get very much statistics all the time. So I think we're not that good at GUI. We're more like on profiling. So thank you.
Hi. One of the problems I've had with time series data is that there is some catastrophe or incident, and you get a massive spike or fail or valley or something that throws off all your aggregates for, days or even weeks. Is there any method to excise a known bad data set from the time series data so it doesn't mess up your checks for however long your sliding window is for consideration?
Yeah. No, it's not today. You cannot sort of delete it due to. But that's an interesting thing. What you can of course do is you can apply math. So you're taking away the impact of that spike very much then. But that could be interesting. I don't know if you think about it as a cleanup thing. You want to take them away because in this time interval.
My experience has been in plotting performance. It's mostly for visualization, not necessarily for checks. But in visualization, you'll have an incident where it's a couple of orders of magnitudes high for a day,
Yeah.
and then all of your graphs for the next week are unreadable because it scales it to
Yeah.
to take that data point into,
Yeah, that's
into
right.
consideration.
Yeah. A good point.
Yeah, that would do it.
Mm.
Sure, that would take the edge off. Yeah, I was typically just dealing in averages, but that would probably be a more effective way to approach it.
And that's also an interesting point that, I mean, in the system now you have average, median, mean, or max, mean, and that sort of stuff. But this is also what we see. People would like to implement lots of different things, and they should also be just dropping them in there, and they will be class-loaded as part of all the other stuff. So there is a way to write this sort of math operations.
I'm not sure that I understand the role of Nagios in the overall checking scheme of this. So I understand BizCheck's collecting all the statistics. It's got the information. Are you still setting up a service with checks in in Nagios that then asks BizCheck to respond with a status?
Well, what you do is that from a Nagios perspective, BizCheck looks like any other source that sends a passive check to Nagios. So, I mean, so in that way, we are no different from anything else. So everything that has to do with graphing and what groups to be notified, etc., is done by Nagios. So there's nothing different. It's like what we talked about yesterday, you and I. It's a dead simple protocol. You send the state and the performance string. So that's mainly what we do in two. So from your normal Nagios installation, this will work like any other passive source, passive check source.
All right, if I don't think there's any more questions, then I think we're going to break for an hour and a half for lunch. So give them a big round of applause. Thank you all for coming out.
Thank you very much.